All right. Now that we've gone through all of the conic sections, we've dealt with circles, ellipses, hyperbolas, and parabolas. We want to give you a way to help you remember or recognize what type of conic section you would graph just by viewing the equation. So that could be valuable when you don't need to know all the information about a certain conic section. You just want to figure out what kind of picture it would be. It's very, very useful for our this class and our future math courses. So sometimes they're quite obvious because they're in the nice familiar form that we're used to seeing, but sometimes they're not quite so obvious. So I always like to start off with kind of like process of elimination. And if I could notice for myself, I always like to look at if I only have one term that's being squared, that's my heads up about I'm going to have a parabola. So if I look at part A, I notice that both terms are being squared. So that's not a parabola. If I look at part B, right away, I only see the x squared. So I can automatically identify that first. So parabola. You know, a bonus if you want to talk about horizontal or vertical parabola. But right now, all they just want you to figure out is which of the four. If we go to part C, again, even though it's not quite in a nice form that you recognize, you do see only one of the terms are squared. So that's another heads up that you've got yourself a parabola. So it's not quite pretty, but that's all we have to guess from here. We do see that if I look at part D, part E, part F, I have another situation where I do see only one of the terms being squared. That one looks like it's in one of the forms we have studied. So that might also be a bonus for you. But I'll also categorize that as parabola. So now I've got all the parabolas taken care of. The next thing I'll try to understand for myself, usually we're either looking what we have circles, ellipses, or hyperbolas. And so when I go with determining the circles, ellipses, hyperbolas, I always want to recognize that in all of those equations, both of the variables x and y are being squared. So if you look at part A, part D, and part F, those are all being, both x and y are being squared. So we would try to see if we can rewrite the equations in the forms that we're more familiar with. So if I look at part A, I'm going to move it out a little to the right. I see that the y square is on one side, the x square is on the other side. So it might be useful if I were to subtract 4y squared from both sides. So that's going to give me 25x squared minus 4y squared equals 100. And I don't have to go further, but you can. I already noticed that I see a minus sign. So right when we have all the x squared and the y squared on the same side of the equation, you could automatically tell for yourself that we've got ourselves a hyperbola. If you want to take it further and just justify it for yourself, we could divide everything by 100. So we can see the nicer form. So we would have x squared over, let's see, reducing 25 over 100, x squared over 4 minus, this would be y squared over 25 equals 1. That kind of makes it a little bit more precise as to what type of hyperbola you would have. But remember, the example and directions are only asking you to identify them. They don't really want too much more information. So feel free, pick up the patterns. So we're going to look at the same idea for part D. I do see both of the variables are being squared, x minus 4 squared, y plus 1 squared. Perhaps it's a little nicer if I move the squared terms on the same side. So this would involve me probably adding y plus 1 squared over 4 to both sides. I'll squeeze that in there. I know you can mentally do that, and that's fine. So I have x minus 4 squared over 25 minus, excuse me, it is plus y plus 1 squared over 4 equals 100. And right away when I'm looking at it, I see a plus sign. And I do see different numbers in the denominator. So it's a heads up that I am going to have an ellipse. But if we want to take it further to just verify a little bit more, we could divide both sides by 100. And if you divide by 100, you'll be multiplying by 100 in the denominator. And even though the denominators look a little scary, you end up seeing, let me write that a little nicer for you. We have 2,500 in the denominator, y plus 1 squared over 400 equals 1. That gives us a better idea of what our ellipse would be. Like the major and minor axes would be huge in this case. But it also lets us understand that the denominators are different numbers. So that's why we have an elongated sort of ellipse. It's actually going more horizontal. But again, like I said, all you have to do is be able to identify what that equation is. So one last one, if I'm looking at part F, I'm going to notice that I've got a plus sign. That's separating the squared terms. So I have x squared and y squared on one side and 100. Now, one might say ellipse, and you would be correct. So you can say that. But more precisely, we'd want to dive into this a little bit more. If you can divide every term by the 100, I think I just kept all the 100s in the examples just to make it easier on ourselves. We would get x squared over 4 plus y squared over 4 equals 1. And yeah, that could be a version of the equation of the ellipse. But I would like to point out, when you look at your denominators, they both end up being the same. So if you were to draw a quick sketch of what you would get, you're not going to have a wider graph in any direction. What you end up having is more of a circle. So for full credit, you would want to call this equation a circle, because a circle is a special version of an ellipse. So kind of keep that in mind when you do have an ellipse case. You're always kind of double checking one more time to make sure your denominators are in fact different. In that case, you do have an elongated sort of circle, would be an ellipse. And if you have the denominators that are both the same, you actually have a circle, because you're the same direction all 4 guide points. So I hope this gave you some insight on how to identify the conic sections just based on the equations. Feel free to practice, and I will see you in the next section.